Okay, we're going to continue now. So what I'm going to do is I'm going to plot a few more points on the number grid, and this should be on the back page of your notes. So we've already looked at the vector A, and the vector A is -4, 6. I've put that as a red arrow on the screen. We can also, I'm going to call this vector here, from F to D, we're going to call it vector B. Now vector B you can see is 4 across and 1 up, so that'll be 4, 1 if I were to write it. Okay, so the question, this is a classic question, and it will be something like, in terms of A and B, what is, and then it's going to list some things. So OB would be from the origin to B. How do you get from O to B using vectors A and B? How do you get from G to D? And how do you get from B to E? So if you think you're comfortable with all of this, maybe you could pause the video now and have a go at these. But if not, just join me on this journey. So from O to B you can see is 4, 1, and that is just the vector B. Okay? And it's the same as, I think that should be from F to D, really. Oh, sorry, yeah, we can, I was going to talk about this in a different way. So we can actually think about going from O to B in a different way. If you were to travel from O to B, you could go from O to F, then from F to D, and then from D to B. Now with vectors, what's quite nice is it doesn't matter how you get to the end goal, how you get there, as long as you get there in the end. So if we were to look at it in a different way, we can see clearly that O to B is just B, but no matter which direction we take, as long as we end up where we should end up with the same thing eventually. So I'll show you how this works. O to F you can think about as being the vector A. Okay? That should be quite obvious. It's the same as the vector from B to D. So O to F is A. F to D is the vector B. And D to B, well, that's not A, that's negative A because you're going in the other direction. Okay? And if you were to cancel that, A, vector A plus B plus vector minus A would just leave you with vector B. So as I've said, it doesn't matter how you get there as long as you end up at the end point from where you started, and everything should cancel to leave you with the same answer. If we're going from G to D next, maybe using the ideas we've just looked at, you can do that yourself. So if you're not sure, you could think about going from G to F, and then going from F to D. That's the same as going from G to D. You end up at the right place. So G to F, well, that's going 2 lots of the vector A, and F to D is going the vector B. So the answer is 2A plus B. Or you can think about it as, another nice thing about vectors is if I write it in vector notation, 2 lots of the vector A plus the vector B, like I've written here, 2 lots of -4, 6 plus the vector 4, 1, I can sort of do things where I add vectors. Okay? So if I look at this, 2 lots of -4, 6 will just be -8, 12. That sort of makes sense. Plus the vector 4, 1. What's quite nice, when I add vectors, I can just add the x values. In this case, the x values we know are -8 and 4. That's the direction, that's the x direction. And the y values, the 12 and the 1. If I add -8 and 4, I get -4. And if I add 12 and 1, I get 13. So this means, okay, that if I go directly from G to D, I should go the vector -4, 13. And indeed, if I were to draw this, -4, 13, if you were to count the squares, you would go 4 to the left and 13 up. So this is how you could add vectors. The final answer, by the way, is the answer in blue there, the 2A plus B. But I'm just showing you how you can add vectors and how you can multiply them by a number. So multiplying them by 2 doubles the x and the y values, and then adding vectors, you add the x values and you add the y values. Okay, let's look at B to E. So B to E, maybe pause the video and see if you can do it yourself. You can think about B to E though as going from B to O and then from O to E. There's different ways you could do it. You could have gone from B to C and then from C to E, or you could have gone in a long direction. You would end up with the same thing, hopefully. So from B to O, well, that's going negative B. And then from O to E, well, it's not A, and it's going in the other direction. It's actually negative a half A. This is a half of A, but it's going in the other direction. So this would be the final answer for this question. And that's a nice little diagrammatic representation of it. Okay, so we've looked at some questions involving vectors. We looked at how to add vectors. We're going to look at now something that could come up. It rarely does, but it does come up occasionally. It's something called the magnitude of a vector. So the magnitude of a vector, when I'm talking about magnitude of a vector, I'm talking about the length of a vector. Now when you think about lengths of vectors, well, we can use Pythagoras, and we are going to use Pythagoras whenever we're doing a length of a vector. Okay? So the magnitude of B, let's say, what is the magnitude of B? Well, that's the length of B. Sometimes, I don't know if it's written like this often, but you could write it as B inside 2 lines, the magnitude of B. So what is B? Let's draw B. B goes 4 across and 1 up. Okay? 4 across and 1 up. So the length, the magnitude, is this red dotted line here. How long is it? You can see that it's just a right angled triangle, so it's very straightforward to use Pythagoras. So I can say it's the square root of 4 squared plus 1 squared, which is the square root of 17. So the magnitude of B in this case is going to be root 17. You might, if you're told, you might round that to 3 significant figures, but root 17 for now is absolutely fine. Okay, so this is everything you need to know about vectors for IGCSE. We'll do some practice of vector questions and lessons, and we'll get more comfortable with this notation. I think it's kind of fairly straightforward, but the new notation might be a little bit intimidating. Okay, thanks for watching.